welcome again into Broad Concept, and today we're going to talk about acids and bases, or in other words, acids and alkalis. So you might ask yourself a question: why acids are that important? Why we talk about them in the first place? Well, basically, as probably everyone knows, an acidic substance is something that has the potential to break down or to injure or to dissolve other substances, materials, etc. So those substances are actually quite important, not only for living organisms, but also in geology as well. We ourselves, humans, we are using hydrochloric acid in our stomach to actually break down the content of the food that we eat and make it a bit more easier to digest. So before we can get to the details of acids, bases, pH volumes, how it is all connected together, let's quickly recap the basic informations about atoms, because essentially those two elements are tied together. So inside of an atom, inside of the nucleus, we would find a proton that is positively charged, and we would find a neutron that has no charge. On the outside orbits, we would find electrons that have negative charge. Now, we also said that on occasions, those electrons can be kind of thrown away, or the electrons can be actually accepted into the outside orbits. So in those cases, we would talk about ions of a substance or ions of an atom, right? So if the number of protons exceeds number of electrons, we would talk about a positive ion, and if the number of electrons exceeds the number of protons, we would talk about a negative ion, and that will actually become quite important in just a bit. Now, the element that determines whether a substance is an acid or base is known as hydrogen ion, a positively charged hydrogen ion. But also hydroxide, a negative ion, is equally important. So we can say that an acid is a substance that donates hydrogen ions, those positive hydrogen ions, into the solution, and an alkali is a substance that is able to accept positive hydrogen ions from a solution. So looking at that, we can see how the amount of positive hydrogen ions regulate the acidity or the base, or generally pH of the solution. In the description, I will leave a link to one article and one video that actually explains in a fairly good way how the positive ions of hydrogen and negative ions are formed, because that actually does require going a bit deep into the details. But what we are interested actually is the pH. So how we can in fairly easy way see whether the substance is acidic or whether it's an alkali or base, in other words. So very often you would come across a scale with numbers, and basically what it tells us is how much of positive hydrogen ions we have, right? So the neutral value of pH is 7. That is actually expressed in moles. So in other words, in very small quantities. Again, you can research that. It does involve a bit of mathematics as well. But if you want to look from a very simplistic point of view, you have the scale. 7 means that the substance is neutral. Or in other words, because the pH is calculated as a minus logarithmic value from the numbers of hydrogen positive ions, we say that in pure water in the room temperature, the number of those hydrogen ions that are positively charged is 10 to minus 7. So if you put that into the equation, if you calculate on your calculator minus logarithmic value from 10 to minus 7, you will get simply 7. So now if we add to our neutral solution some of the positively charged hydrogen ions, we will increase the number of those in the solution. Therefore, you wouldn't have 10 to minus 7 anymore. You would have, say, 10 to minus 2 instead. And again, if we calculate minus logarithmic value from 10 to minus 2, you would have a pH of 2, so an acid. Now, on the other hand, if we add OH minus, so negative ions, into the water, what we will actually do, we will decrease the value of positive ions of hydrogen, because OH minus, when combines to positive hydrogen ions, it will actually form water. So in our equation, instead of minus logarithm 10 to minus 7, we will have, say, minus logarithm 10 to minus 10. So again, if we calculate that, our pH will be 10, which means it's a base or alkali. So that's it for today. I hope you have enjoyed the tutorial. As always, leave comments, have a look at the description, visit the links and subscribe. And see you next time. Cheers.